Have you ever looked up at the moon and thought it feels close enough to almost touch? Of course, although that moment is special, the feeling is an illusion.
At its closest, the moon is over 360,000 kilometres away. So far that you could fit around 30 Earths between here and its surface. And yet, despite that distance, we've been there 6 times. Right now, more than half a century-old footprints still mark the grey, lifeless dust. But from Earth, we see none of it.
So, what happens when we aim a powerful telescope at those exact Apollo landing sites? How much can we actually see from here?
So what exactly are we trying to see on the moon? Well, between 1969 and 1972, 6 Apollo missions landed astronauts on the lunar surface. And when they left, they didn't take everything back with them. In fact, more than 800 individual items were left behind. I actually made a fascinating full video about the more strange and surprising items still sitting on the moon today. You can watch it using the link in the description after this video if you like. But focusing on the more larger objects, right now completely untouched, the descent stages of the lunar modules still stand exactly where they landed. 3 lunar rovers remain parked where their final drives ended. Scientific experiments designed to study the moon still sit exposed to space. Even the astronauts' footprints and rover tire marks, which created large patterns in the regolith, remain untouched by wind or rain for more than half a century. Nothing rusts there, nothing erodes quickly, nothing washes away. The moon is a time capsule. If you could hover just a few kilometers above these landing sites, the signs of human activity would be unmistakable. And that naturally leads to a simple assumption. If all of this is still there, and we have telescopes that can reveal mountains, valleys, and craters in extraordinary detail on the moon, then surely we should be able to see these landing sites from Earth, right? For anyone who has ever set up a telescope and pointed it at the moon, you'll know there's a perfect moment when suddenly the image snaps into focus. The moon no longer looks like a distant grey, patchy disk in the sky. It looks like a place, a world that can be explored. And with even a modest backyard telescope, you can begin to explore its surface in remarkable detail. You can follow the bright rays of Tycho crater stretching across the lunar plains. You can trace the rugged mountains surrounding Mare Imbrium. And you can clearly see the dark, smooth regions where ancient lava flooded the moon billions of years ago.
Then, naturally, once you've taken in the moon's magnificent landscape, the next step is to look for one of the only physical links humanity has to this world: an Apollo landing site.
Let's start with the most famous location of all, the Sea of Tranquillity. This is where Apollo 11 landed in July 1969. Through a telescope, the region is easy to find, a wide, dark plain surrounded by brighter highlands. You can center it perfectly in view, then zoom in. You can continue to increase the magnification until the image becomes razor sharp. But no matter how much you zoom in, the only thing you will ever see is the moon's grey, desolate landscape. No flag, no landing module.
No sign that anything extraordinary ever happened there.
But the Apollo landing site hasn't eroded away or been buried beneath dust. There's no wind or rain on the moon, as we have already established. So where is the Apollo 11 landing site? Well, as I mentioned at the very beginning of this video, the moon sits at its closest over 360,000 kilometers away. And despite how small it appears in our sky, it is still unimaginably large compared to anything humans have left upon it. This is the Apollo 11 landing site. It's just that the entire site is within this single pixel of detail.
You might think next, well, we need more magnification. Let's use the biggest, most powerful telescopes we have. But the answer isn't really about magnification, it's about resolution.
You can magnify the moon by 1,000 times, but if your telescope's aperture, which is the diameter of the main lens or mirror, is too small, you will only see a larger, blurrier version of the same features. So a bigger aperture means better resolution, which gives you the ability to distinguish smaller objects. You can think of it like a light bucket. Just as a wider bucket catches more rain, a wider aperture captures more light. And that's exactly what you need to get better resolution, and so see those smaller features. But there's a problem, because even under perfect conditions, the biggest optical telescope on Earth, which is nearly ready for its first light, named the Extremely Large Telescope, is still unable to resolve the Apollo landing sites, and this telescope has a reported primary aperture of 39 meters, which means it will gather 15 times more light than any other operating optical telescope on Earth at the moment. And yet, even with this enormous light bucket, every Apollo landing site still is less than a single pixel of information.
So how big would a telescope need to be to see these famous sights?
Well, let's first consider how small the Apollo hardware actually is. The Lunar module descent stage is only about 4 meters wide. The Lunar rover is smaller still, and astronauts' footprints measure just centimeters across. So to make these sites less than a speck, it is estimated that we would need a telescope with an aperture of 200 meters in diameter. Theoretically, it is possible to build, but it would push the absolute limit of current engineering and of course cost many billions of dollars. Even the 39-meter extremely large telescope has a current construction cost of over $1.6 billion. So despite all of our technology, no telescope on Earth can directly image the Apollo landing sites from our distance. They are simply too small.
But it turns out we don't need a telescope here to see the landing sites. We've already photographed them in pretty good detail.
This is the clearest image we have ever taken of the Apollo 11 landing site since Neil and Buzz left more than 55 years ago. And what it reveals is unmistakable. You can see the descent stage, the laser-ranging retroreflector that is still functional today, the seismometer and the TV camera that filmed the astronauts as they launched back into space. You can even see the faint path they walked for the brief time they were exploring there. And if you look at the later landing sites, like Apollo 17 for example, you will see that the confidence of the astronauts was far greater, as they travelled farther away from the lander in their lunar rovers, leaving their tracks forever etched in the lunar dust. These are not reconstructions, not artist impressions, but real photographs. So how did we get these incredible images? Well, in 2009, NASA launched the Lunar Reconnaissance Orbiter, or LRO, a spacecraft designed to map the moon in extraordinary detail. Rather than observing from hundreds of thousands of kilometers away, LRO orbits as low as 20 kilometres above the lunar surface. From that distance, its cameras can resolve features less than a metre across. And for the first time since the Apollo era, humanity saw all of the landing sites again. So if we ever want to see these landing sites in far greater detail, there's only one way to do it. We have to go back. But when you look up at the moon tonight, remember, you are looking at a place forever changed by human hands, where human footprints are still pressed into ancient dust right now, preserved for likely millions of years into the future. They are evidence that for a brief moment in history, our species stood somewhere else. And yet, from here, that evidence remains completely unseen.
That isn't me, that's AI. And the reason I'm showing you that is because content like this is becoming increasingly common, especially in space and astronomy. But V101 Space is built differently. This channel is researched, written and narrated by me, a real human who actually checks sources and cares about the stories behind each video. That's why I created the V101 Alliance, a membership offer that for less than the price of a coffee each month allows people who values this kind of content the chance to support it directly, and in return get meaningful perks. So if you'd like to join this mission and become a part of the V101 Alliance, become a member today for just $2 by clicking the join button that's located next to the subscribe button. I would love to welcome you, and hopefully I'll be seeing your name in one of my future videos very soon.